Hello, my name is Barry Lefer. I am the program scientist for tropospheric composition at NASA headquarters. Today I would like to tell you about the MAIA and TEMPO satellites that are NASA's future of air quality satellite observations. According to the World Health Organization, 90% of the world's population is breathing unhealthy levels of pollution. Numerous epidemiological and economic studies have shown that air pollution results in premature deaths of almost 5 million people annually, and that illnesses due to air pollution cost over $20 billion in healthcare expenses each year. In the 21st century, poor air quality is often preventable. We already have the technology to remove pollutants from smokestacks and tailpipes. And in several countries, the transition to cleaner energy sources and non-emitting vehicles has already started. The 1970 Clean Air Act authorized the U.S. Environmental Protection Agency to establish the national ambient air quality standards to protect human health and the environment. In 1971, the EPA defined what dangerous levels of sulfur dioxide, particulate matter, carbon monoxide, ozone, and nitrogen dioxide should be. Later, in 1978, EPA established an ambient air quality standard for lead as well. The Clean Air Act also requires that these standards be reviewed every 5 years to make sure that they are still protecting our health and the environment. The good news is that the Clean Air Act has been highly effective in reducing all of these 6 pollutants. And as of the 2020s, the only EPA criteria pollutants that are at unhealthy levels in the US are ozone and PM 2.5. The bad news is that the American Lung Association 2020 State of the Air report analyzed the official EPA data and determined that approximately 46% of the U.S. population live in counties with unhealthy ozone or particulate pollution levels. NASA believes the best way to understand and better forecast air quality is to create an integrated observing system that includes satellite observations, ground-based monitoring data, and airborne measurements that all inform 3D chemical transport models. This integrated system only works if NASA partners closely with other state and federal agencies as well as international collaborators. Here's a map of particulate mass observations readily available online in near real time from FIREX-AQ. While there are numerous PM sensors in the US, Europe, and Asia, the dearth of monitors in South America, Africa, and the Middle East is quite noticeable. In many parts of the world, satellite air quality data might be the only information that they have. Unfortunately, most satellite instruments only measure the total amount of pollution in the atmospheric column and are not able to distinguish how much pollution is in the surface layer that people breathe. Consequently, much of NASA's air quality and health research is about how to transform our satellite column data into useful surface information related to human health. NASA's Multi-Angle Imager for Aerosols, or MAIA, aims to understand how different types of aerosol particles affect human health. The MAIA satellite instrument will collect wavelengths of reflected sunlight at multiple angles, which will allow it to determine the size distribution of the particle pollution. In addition, MAIA will sample reflected light at multiple polarizations, which will reveal something about the shape and type of aerosol particles. When clouds obscure MAIA's view of a particular city, the team will rely on high-resolution models to help fill in the data gaps. Together with epidemiologists, the mission hopes to gain an improved understanding of what types of particles are most harmful to human health in each of their target cities. The 12 MAIA primary target cities each have ground-based monitors to help improve our understanding of the satellite total column aerosol optical depth to surface PM 2.5 relationship. These 12 cities already have ongoing epidemiological studies, and these same health scientists are already part of the MAIA team. So when the MAIA instrument launches in 2022, we'll be ready to start taking a closer look at the relationship between air quality and health. This map shows the 205 U.S. counties where more than 137 million Americans still breathe unhealthy levels of ozone. Ozone is a highly reactive trace gas that is not directly emitted by a smokestack or a tailpipe, Rather, it is formed downwind in the atmosphere by chemical reactions involving nitrogen dioxide, volatile organic compounds, and sunlight. The NASA Tropospheric Emissions Monitoring of Pollution mission, or TEMPO, will measure some key elements of air pollution chemistry. The TEMPO instrument will be on board a geostationary satellite positioned at 90 degrees west to monitor the hourly evolution of trace gases such as ozone, nitrogen dioxide, and formaldehyde during the daytime across North America. The unprecedented observations from TEMPO will enable detailed studies of events such as wildfires, volcanic eruptions, and dust storms, as well as traffic, industrial, and agricultural emissions. The TEMPO mission is a collaboration between NASA and the Smithsonian Astrophysical Observatory. The TEMPO instrument was built by Ball Aerospace and is currently being integrated onto a Maxar 1300 series spacecraft bus and will be part of an Intelsat commercial SATCOM mission to be launched on a SpaceX Falcon 9 in the fall of 2022. This animation of synthetic TEMPO data shows the hourly east to west scan pattern of the TEMPO instrument. The TEMPO instrument will have an unprecedented high spatial and temporal resolution across this field of regard that extends from Puerto Rico in the southeast to the Aleutian Peninsula in the northwest. The east to west scan of North America is likely to take less than an hour, which will allow time for the TEMPO instrument to observe interesting air pollution events in more detail. The TEMPO mission will sample gases that react to form both ozone and PM2.5, and therefore give us a better chance to understand the sources of North American air pollution. The TEMPO mission is joining two other geostationary satellites measuring air pollution in other parts of the world. This international collaboration will aid in the study of pollution sources and transport on timescales never observed before. The South Korean project GEMS launched in February 2020 and has already started collecting measurements. The European Space Agency plans to launch their Sentinel-4 satellite in 2023. These three satellites will be able to give scientists a more complete picture of air pollution across the Northern Hemisphere on an hourly timescale. The Sentinel-5P TROPOMI and OMP satellites are currently obtaining once-per-day global coverage of the same gases that TEMPO and the other geostationary instruments sample. Collectively, these 5 or more satellites are known as the Atmospheric Composition Virtual Constellation, which will be combined with chemical transport models as well as the ground and airborne observations. This integrated observing system will dramatically improve our ability to understand, monitor, and predict air quality and to protect human health. Thank you for your time. Here are the links to the TEMPO and MAIA websites if you need more information. Take care and have a happy AGU.